You are welcome to today's video lesson with Bright Edo. In today's lesson, I'll be discussing about a very important gas law, and it is called Lussac's law of combining volume. Now, this particular topic is very important for the Jamb examination and other related exams. Okay, whereby in this video lesson I'll be discussing step by step how to solve questions under this aspect. So with all this said, let's quickly go over to state what Lussac's law is all about. Now, this must be noted. It must be noted that Lussac's law of combining volume states that when gases react, they do so in volume. So it's trying to say here that let's say we bring two gases and we react the gases together. The way these gases will react, they will react in terms of volume. That's why the word here is in volume. So when gases react, they do so in volume, which are in simple ratios to one another. So these gases that are reacting in volume, we have simple ratio to one another, and so the volume of the product, if gaseous, provided temperature and pressure remains constant. So this product, the product we are to get in the reaction will still be in the term of volume. Don't worry, in the course of this video class, I'm going to explain how this concept works so easily. So with all this said, let's take an example. So from the law, when gases react, so let's say we take a particular gas and this is the reaction I'll be working with. Okay, let's say we take a particular gas. Okay, so when gases react, let's say we take this gas, which is hydrogen gas, reacting with, let's say, with another gas like oxygen gas. So when hydrogen gas and oxygen gas react, they must be in gaseous state. So this must be noted. So when hydrogen gas and oxygen gas react, we'll basically get steam. Okay, that's gaseous water. Water in the gaseous form. So we'll get H2O, which is gaseous. So this particularly is called steam. So when gases react, they do so in volume. But in the look of things, this reaction is not yet balanced. We have to balance the reaction. Doing that, you can see we already have two atoms of hydrogen. And how many atoms of hydrogen here? Two. Hydrogen is okay. But oxygen here is two atoms. But here is just one oxygen atom. So what do we do? I think we have to put two here. Doing that, this oxygen atom becomes 2 and hydrogen now changed to 4. So definitely this oxygen is already 2 and we are still to put 2 here so that the hydrogen in the left hand side of the reaction becomes 4 and the hydrogen here also becomes 4. So the point here is this about the Lussac's law of combining volume. It states that when gases react, they do so in volume. Because normally in a stoichiometric reaction, we have to write their mole ratio. So in the look of things, because of these two here, we have to write 2 moles of hydrogen gas react with how many moles of how many moles of oxygen? You know, there's an invisible one here. So here become 1 mole of what? Oxygen gas to give us what? To give us 2 moles of steam. Okay, from a normal stoichiometric mole ratio balancing. But you know, we are talking about the Lussac's law of combining volume, and what it states is when gases react, they are gases, they do so in volume. So it means that all these values are supposed to be in the volume unit or volume SI unit. So here we now have volume ratio. Okay, so here basically becomes 2 volume. Okay, because we are reacting the gases in volume. 1 volume and 2 volume. But to be specific, we have to write the unit to which the volume is existing. And in the course of this video class, and also in the course of questions that are being asked on this aspect, they use the volume most times in cm cube, that's centimeter cube. So here become 2 centimeter cube, 1 centimeter cube, and 2 centimeter cube. That's what Lussac is trying to say. He's trying to say that when gases react, they must react in volume, which are in simple ratios to one another and to the volume of the product. So this product is still going to be in terms of volume, okay, if gaseous, provided temperature and pressure remains constant. So this particular word here means that we don't use temperature and we don't use pressure, the values given, because definitely temperature and pressure most times will be given in the practice question, but when solving we don't use these parameters. As we go ahead to solve the first practice question, you get to understand perfectly how this particular law, which is the Lussac law of combining volume, works so easily. So if you've not yet subscribed to this channel, do well to hit the subscribe button and also share these video lessons with your friends so you don't miss out new video lessons to be out very soon. So with all this said, let us progress to start solving practice questions. Okay guys, let's get into the first practice question. And as I solve this practice question, you have to pay close attention to every single steps that are being followed to solve this practice question. It is so much very easy. So if you've not yet subscribed to this channel, do well to hit the subscribe button and also share these video lessons with your friends, particularly this particular video lesson on Lussac's law, because students find solving questions on this aspect difficult. But I believe after watching this video lesson, this particular aspect will become so easy. So let's get into this practice question. Now I read. The question says, if 18 cm cube of nitrogen gas was mixed with 21 cm cube of hydrogen gas. Now let me explain, because we have numerous ways questions can be asked under this aspect. Sometimes you will see if 18 cm cube of nitrogen gas was packed, it's still same as was mixed. And you can also see another word, was reacted. So all these terms are actually same. Okay, so if 18 cm cube of nitrogen gas was mixed or was packed or was reacted with 21 cm cube of hydrogen gas at 450 degrees Celsius and 200 atm. Now, in the look of things, I'm not done reading the question, but in the look of things, nitrogen is reacting with hydrogen gas. And this particular reaction that is occurring brings my mind to a type of reaction, an industrial process called the Haber's process. Okay, this is a reaction used to form ammonia, and it is called Haber's process. It works best at 450 degrees Celsius and 200 atm. For we to yield ammonia optimally, we basically, the reaction basically occur at 450 degrees Celsius and 200 atm. That is why this particular value was here. Okay, and I earlier said that we don't use these values to solve questions under this aspect. We are just giving, okay, to confuse us, or if we are to use these particular values to solve questions, but we don't use it. I'm going to explain how to solve questions under this aspect step by step. Meanwhile, the last part of the question says, calculate A, volume of excess gas, B, volume of residual gas. Now, this must be noted. It must be noted that the word excess gas can also mean volume of unreacted gas. This must be noted. Now, you can see, now, first of all, let's write out the equation for this reaction. So here will be an equation. So from this reaction, hydrogen, first, nitrogen gas, N2, you must put this, word, gas, reacted with what? Hydrogen gas. Okay, and as I earlier said, what should be our product? The product here we are to get is ammonia, NH3 gas. And for this reaction to work optimally, basically it must occur at 450 degrees Celsius and 200 atm. And for it to basically form ammonia so quick, we'll use a catalyst. Catalyst speeds up the rate of a chemical reaction. But what speeds up the rate of biological reactions are called enzymes, which are organic catalysts. Okay, so moving further here, so for it to form ammonia, okay, very fast, we use a catalyst called finely divided ion. But right now, we are not interested with that. What we are interested in to solve the volume of the excess gas and the volume of the unreacted gas. That is what I'll be explaining step by step on how to do that. So after solving this particular practice question, I'm going to give you yours to solve and provide the answer in the comment section below. Okay guys, so the first step to take here when solving practice question under this aspect, which is Lusac's law of combining volume, we have to balance the reaction. So in the look of things, this is the reaction, and you can see that the reacting species and the product all are in gases. Now this must be noted. It must be noted that Lusac's law basically works when the reacting species and the product are in gases. So we can't have liquid. So if we have liquid, it will not count when solving practice questions under this aspect. I'm going to explain as we progress. Okay, so moving further, let's balance the reaction. So let me put 2 here in front of ammonia. Doing that, we are having 2 moles of nitrogen, and here how many? 2 atoms of nitrogen also. You can see here that we are having 2 nitrogen here and also 2 nitrogen here, balanced. So for hydrogen, here is 2, and automatically this hydrogen we are having here increased to 6. Okay, because we are having 2 times 3 now, 6 atoms of hydrogen. So for me to balance hydrogen here, I'll put 3 in the front of hydrogen. So 3 times 2 is also 6 atoms of what? Hydrogen. Now this is the first step to take. Now next thing we have to do here to solve this practice question is to simply write the mole ratio. Okay, because you know that for Lusac's law it states when gases react, they should react in volume. So here becomes volume ratio. But let's just write the mole ratio now here. Because I'm seeing nothing, okay, we just take it to be 1. Okay, there's an invisible 1 here, whereby for this we take it to be 3 moles. We are taking the mole ratio, and here we are taking it to be what? 2 moles. Next step, we'll take here to be, we are working, normally I'm to write 1 volume, but since we already know that here should occupy volume, we'll just change it to 1 cm cube. I told you all that when solving questions, most times on this aspect, volume is always given in cm cube. So 1 cm cube automatically change because we are working with volume. Here becomes 3 cm cube, and here becomes what? 2 cm cube. Now, next thing to do, you have to follow the steps. Very important. Follow the steps, and when you see other practice question, you'll be able to solve it. It's not difficult. So next thing for you to do is to write out the given volume, because they gave us volume in the question. So you simply write it out as given volume. So in the look of things, what are the given volumes? Okay, let's go back to our question. If 18 cm cube of nitrogen gas, so for nitrogen, what was the given volume? 18 cm cube, okay, was mixed. I told that what can also be was reacted or was packed with 21 cm cube of hydrogen gas. So for hydrogen, we are having what? 21 cm cube. So for hydrogen here becomes 21 cm cube, okay, given volume. Did they give us volume for our product? No. Here you just basically write a dash, okay, because the volume for the product was not given. When I'm to give you your practice question, these are the steps to follow. It's not difficult. Follow through these steps carefully, meticulously, so when you see other practice questions under the same topic, you will be able to tackle the question without stress. So you can see what I've been done here. So the next step to take here is to simply write another column here to be normal reacting volume. Now this is where the tags come in place. normal reacting volume. How do we get the normal reacting volume of these gases? That is where we have to solve, and to do that is not difficult, it's easy. Okay, we are to get the normal reacting volume of these gases, and I'm going to explain step by step how to do that. Okay guys, now to get the normal reacting volume of these gases involved in the reaction, be it the reactant and also the product, what we have to do is to follow some series of steps which I'm to explain. Now, first thing first, I'm going to bring out the reactant given in the question. And what are the reactants? Nitrogen gas and what? Hydrogen gas. I'll write them here. Just follow. When I give you a practice question, these are the steps to follow to solve this question without stress. Okay, it's not difficult, it's so much very easy. So I'm going to write here the reactants. Okay, the reactants are nitrogen gas and hydrogen gas. Okay, nitrogen gas and what? Hydrogen gas, the way it was written. Okay, here is what? 3 moles. That's what we have to do. You just bring them out. So in the look of things, let us compare these two gases to see the gas that will take part to power this reaction. It's not difficult, it is easy. Follow through these steps and you get it right. So I'm going to write nitrogen gas to give me hydrogen gas. That's what you should do. Okay, whenever I give you yours, you basically bring the same gases, but I don't think it's going to be same gas, maybe other gases which I'm to balance the reaction for you all. So you bring them, you write them as I'm writing them now. So nitrogen gas to give me what? Hydrogen gas. The way it was written, you bring it out like that. Okay, so moving further, what we are to do, we are checking for the gas that will basically power the reaction so that we can get our answers. Okay, now I'm going to make, because now to do this, there is no perfect way. Okay, we basically just compare and get the most appropriate value. When I solve, I'm going to explain better. So in the look of things, what was the volume ratio for the nitrogen gas? What was it? 1 cm cube. So I'm going to write here as what? 1 cm cube from 1 moles. 1 cm cube to give me, what was the volume ratio for hydrogen gas? 3 cm cube. Now, after doing this, I'm to make either of the gases constant. Now, in the look of it, I said there is no perfect way, just for you to compare and check the value that will give you the most appropriate correct answer. And I'm going to tell you how to know. Now, next thing for you to do is to basically make one of the gas constant, the given volume. So we'll go over to the given volume and take let's say we are to make nitrogen value constant. So I'm taking 18 cm cube under nitrogen. So here become what? 18 cm cube. All this we are doing is to get our normal reacting volumes. Okay, so I'm picking out 18 cm cube for nitrogen to give me X. So I'm to get the volume of hydrogen gas now. So in this context, what did I make constant? Which value did I make constant? Which value did I make the same? I made nitrogen value the same, 18. Okay, that's what you have to do first. So after doing that, let's check the volume we have to get for hydrogen. If this volume we have to get will fit into this particular volume they gave us in the question as the given volume. After getting the value for X here, if the value we get is basically lesser than the value for the given volume for hydrogen gas, because we are looking for hydrogen gas now, if it's lesser for this hydrogen gas, you are working towards the correct direction. But if you have a value that is greater than this 21 cm3 for hydrogen gas, it means this particular value you've gotten is not. It means that this particular hydrogen gas will not be able to power the reaction. So you now work in the opposite direction. Don't worry, get to understand better as you progress. So because you can see that the volume they gave us for the question, the volume provided for the reaction to work was 21 cm3. So let's make this guy subject. So X cm cube will now be equal to 18 cm cube times 3 cm cube over 1. So X cm cube is going to be, so simply times 18 cm cube times 3 cm cube. 18 times 3, that is 54 cm cube. So automatically here, X cm cube of which of the gas? Is it not hydrogen gas? Yes. Of hydrogen gas becomes 54 4 cm cube. Okay, 54 cm cube. Now you can see that the value we had for hydrogen gas is already greater than the value they gave us in the question. That means this will not work because the volume for hydrogen gas is already greater than the volume they gave us in the question, so it won't work. It can't occupy the normal reacting volume because we are trying to get the normal reacting volume, so it won't work. So you walked in the other direction. Remember I said that let's say we got a value that was lesser than 21, it's going to work. Okay, but you can see now it's greater because we know we are working with for hydrogen gas now, because I make nitrogen constant. So the next thing to do now is to do the reverse by making hydrogen constant and looking for the value for what now? Nitrogen gas. Okay, so doing that, you can see that we have 54, so it can't occupy the normal reactive volume for hydrogen gas. It won't work. Do you get? So moving further, let's take the opposite direction. It's not difficult. I'm going to explain summarily how this concept works without stress. So let's clean and make the order that we not make a constant now. So in the look of things, nitrogen gas from the volume ratio was 1 cm cube, and this is what 3 cm cube. So moving further, we are to make, because we make nitrogen constant. So here now, we are to make which of the gas constant? Hydrogen gas, by using the value 21 cm cube. So here it becomes 21 cm cube, whereby here we now say we are looking for nitrogen, because the sole aim of doing all this is to get the appropriate values for the normal reacting volumes. After getting this, we can simply go ahead to solve all this. The questions given in the questions provided here, they are all very easy. So let's check, because first thing first, I made nitrogen's value constant. Okay, that 18, I made it constant, so we made it x to get our answer. But you can see that the answer, the volume for hydrogen we got was now greater than the volume given, so it won't work. Okay, the reaction cannot proceed in that direction. So that's why I changed the way the reaction should work. So I made here x now, and here made it constant. That is how you should solve whenever you see questions under this aspect. Okay, it's like, because there is no formula to solve questions under this aspect, so we have to basically compare various gases. Okay, now you can see here that I have made hydrogen gas constant before we made nitrogen, that 18 given constant. So here x cm cube will now be equal to 1 cm cube times 21 cm cube over 3 cm cube. So x cm cube of which of the gas? Of nitrogen gas will now be equal to, so in the look of things, 1 times 21 over 3. Okay, that's 7. So we had the volume of nitrogen gas to be what? 7 cm cube. So you can see now that we're getting this value. We are working in the correct direction, because the volume for nitrogen we had is now smaller than the volume they gave us. So it means that here now, normal reactive, when you've done this and you've seen that the value you've gotten is now is now lower than the volume given in the question, you basically come to your normal reactive volume and simply start filling. Okay, you fill this place and will not solve, because here it's very easy to do this. It's very easy. Now the only task here is for you to be able to get appropriately the normal reacting volumes. Okay, so here it becomes 7 cm cube, because that was the volume of nitrogen gas that actually reacted. Okay, because when we make here 18 and we made here x, you can see that we had 54. That value is so large, it can't occupy this particular position for hydrogen gas. It is greater, and which is not supposed to be so. If we are to use this, okay, it's supposed to be like smaller than 21 cm cube. So you can see that we've gotten the correct value, that's 7 cm cube. So we brought it here. Do you get? So after doing that, now this particular gas we now made constant, which is 21 cm cube. So the point here is the other reactant that is appearing, you rewrite the value as 21 cm cube. That is how it is done. It is not difficult. And now, how do we now get the normal reacting volume for our product? We're going to work in respect to the value we had for the gas. Not this you are making the same. This one you basically solved for. Okay, now how do we do that? So very easy. Since here was 1 mole and here was 2 mole. How do we get the volume of this particular product? You know, here we now change here to 1 cm cube and here to what? 2 cm cube. So how do you get this? So very easy. Let's do that. So nitrogen to give us our product, which is 2 moles of ammonia. So here become 1 cm cube to give us how many cm cube has gotten initially? 2 cm cube. So the next step to take here is to basically write out the volume we had for the normal reacting volume. Please take this value, not all these. Normal reacting, this is the most important thing. So here becomes 7 cm cube to now give us x cm cube, because we are trying to get the volume of our product, because we are trying to fill in our normal reacting volume columns. So doing that, we basically make x cm cube subject. So x cm cube of the ammonia will now be equal to 7 cm cube times 2 cm cube over 1. So x cm cube will now be equal to 7 times 2, that's 14. So the volume for our product is what? 14 cm cube. So what should be here is what? 14 cm cube. So guys, with all this said, you can see that we've successfully gotten the volume for our product. Okay, remember, for we to get the volume of our product, we have to use the value we had. Okay, we solved from doing this. So it's this value that will now power whatever values we are to get as we progress in the video in this lesson. Okay, so you have to understand the principles. So moving further, how do we get the volume of excess gas? To do that, we simply subtract. That's how it works. So easy. You can see here that next thing you just put minus sign and you now write 18 minus 7. That's 11. 11 cm cube. And here, when we minus, what are we to have? We are having 0 cm cube. And here, what are we to have? Automatically 14 cm cube. You can see how it works. So all these values we've gotten will not give us our answer for the question that was asked. Okay, now in the look of things, volume of excess gas. Now this must be noted. For you to know a particular gas that is excess, it is the gas that after reacting we had some of the gas left. Yes, you can see that when nitrogen gas reacted with hydrogen gas, you can see here that all the hydrogen gas was used. So we had here to be 0 cm cube, whereby here we had remaining 11 cm cube. Yes, and since this 11 cm cube is the part of the nitrogen gas that did not react, so it's unreacted gas or excess gas. So with this information gotten, what becomes the volume of gas A now of excess gas, which is basically same as an unreacted gas? It was 11 cm cube. And they cannot say in our other practice question, identify this gas. Which is the gas? Is it nitrogen or hydrogen? It is nitrogen. Now you can see the column. So the gas here is what? Nitrogen. That's the gas that was in excess, nitrogen gas. Now moving further, how do we get the volume of the residual gas? Now this must be noted. Volume of residual gas. Now I'm going to explain how this particular question works. Now to get volume of residual gas, it means volume of remaining gas after all the reaction. Now for this excess gas, we basically look at our reactant. You don't have business with your product. Okay, for you to get volume of excess gas, you look at your reactant, the gas that remains, the gas that what remains. Do you get? So that's how it works. So I'm going to recap how all this was done. It's very easy. Meanwhile, to get the volume of residual gas is the volume of the gas that remains after the reaction. So it's done by a formula which is volume of, volume, I'm going to shorten volume to just VOL, volume of unreacted gas or volume of excess gas, volume of excess gas plus volume of products. That's how you get volume of residual gas, volume of excess gas plus volume of what? Product. So in the look of things, volume of residual gas is going to be equal to, what's the volume of excess gas? Okay, it is 11 cm cube. So here become 11 cm cube plus What's the volume of product? You can see that these are product size. So the volume we had was what? 14 cm cube. So here becomes 14 cm cube, whereby 11 cm cube plus 14 cm cube, that's 25 cm cube. So here now we've gotten 25 cm cube to be the volume of the what now? The volume of the residual gas, the volume of the gas that what remains at the end of the reaction. So you can see how it works. And remember I said that Lussac's law works in the presence of what? Volume in gaseous state. Any particular species, be in gaseous state, is going to follow Lussac's law. So with all this said, let's say this particular product we had is in liquid form. Let's say that, but ammonia is a gas, but let's say it's in liquid form. Okay, so are we to add the volume of the ammonia gas? No. So what becomes the volume of the residual gas? Volume of the residual gas is going to be just 11 cm cube. I said that liquid volume doesn't count in Lussac's law. Do you get? So if this particular product we had was in liquid state, basically we just stop at 11. That's still the volume of the residual gas. That's the volume that remains. So here we will not count for the residual. Residual is the gas that remains at the end of the reaction. And here, because this particular substance is a gas, it is a gas, definitely we have to add its volume. Okay, so doing that, what becomes here? 25 cm cube. So you can see how it works. It's not difficult. Meanwhile, coming back to how this 7 was gotten is, I said we have to compare. You bring out the gases here and write out their volume ratio, 1 cm cube to what? 3 cm cube, and make one of them constant. There is no perfect way that this particular gas is always to be made constant. You have to check. And after solving for one, you see that the value you have for that gas is greater than the one given. You leave that and go for the one that when you solve, the volume you will get will basically be lesser than the volume given. Yes, that is how it works. So you can see that when we make here to be 1 to 3 according to the volume ratio, we will not make a nitrogen gas X. We are just comparing, we are checking. It's not that there's a constant that nitrogen must be X, this must be 21. No. In other practice question, you have to check the way I solved it. Okay, you have to follow the steps and you get it without stress. So X cm cube to give us what? 21 cm cube for hydrogen gas. That was what they give to us. So you now come here to bring out. So we made here constant 21 to give us our X. So cross multiply and make X of them, and we have 7 cm cube for which of the gas? Nitrogen gas. Okay, so that's why here was 7. Initially, when we made here 18 cm cube, when we made nitrogen 18 and made here X, when we solved, we had a bigger number, 54 cm cube, and 54 cm cube for hydrogen gas cannot enter into those reactions because the volume for the gas given initially is 21, so it can't just work. So that is how questions under this aspect have been tackled without stress. Okay guys, this is the practice question you will be solving, and you provide the answer in the comment section below. Meanwhile, you have to follow the steps I give, okay, step by step. You don't have to rush it. You can solve this particular question and provide the answer in the comment section below. Now, if you find this video helpful, do well to click the subscribe button to this channel and also share these video lessons with your friends to help one another. I've made a lot of video lessons in chemistry that will help you improve greatly, and also when you subscribe, you'll be one of the first person to get notified whenever I post a new video lesson. Thanks for watching.